Okay, problem number 9 on page 548 is probably the most similar to what we might put on a test. In this one, we have another drug, hydrocodone bitartrate. Um, and we're given some information about it. The amount decreases at a rate proportional to the amount left in the body. That lets us know that it's an exponential decay problem. And most importantly, we note that we are given the half-life. So we are told that the half-life right here is 3.8 hours, and it looks like we usually have a dose of 10 milligrams. All right, so let's just jump in and take a look at what we're asked to do. First, we're supposed to write a differential equation. So our differential equation, the change in Q with respect to time, equals KQ. That comes from the sentence that says that it decreases at a rate proportional to the amount left in the body. Since it decreases, I know this K value is going to be negative. Okay, part B, I'm supposed to solve it. If we've gotten good at these, we know it's just Q equals Q sub 0 e to the KT, and I have solved my differential equation. And in this particular problem, they're going to ask me to find K in the next part, so we'll finish that out here. So in part C, I'm supposed to find K, and so let's go ahead and start off by putting in half of the amount. So if I start it with the whole amount, perhaps we could use the 10 milligram dose there. Half of that would be 5 that's left after 3.8 hours. So we're going to put 3.8 right in there. First step is to divide 5 by 10. So we've got 0.5 equals e to the 3.8 k. We're going to take the natural log of both sides. And then we're going to use our calculator to get an answer. So natural log of 0.5 divided by 3.8. So here we go. Natural log of 0.5 divided by 3.8. And we've got our K value, which looks to be negative 0.182. Look at that again. Let's throw in the 4 too, just to be safe. Okay, so now we're on to part D, where we're asked how much of a 10 milligram dose is in the body after 12 hours. Well, let's put our whole formula together here. We've got Q equals, we're starting with 10, so we can go ahead and put 10 in there, e to the negative 0.1824 t, and to solve this one, we're going to put 12 in for t. So we're going to have Q equals 10 e to the negative 0.824 times 12. So then we can just go ahead and put that in here. So we've got 10 second e. Nope. Let's try that again. 10 second. There we go. There's my e to the x. It does not look like e because I'm going the wrong place. There we go. My eyesight is going, I think. 10 second, there we go, e to the x. And you know that number, rather than rounding it, it's sitting right there. So I'm going to take second answer times 12. And there's my answer. The amount that's left is, except I can't see it, 1.12. So 1.12 milligrams is going to be left after 12 hours. Now let's just consider for a moment, does that make sense? So let's see, I've started off with 10 milligrams and I have a half-life, I'll go back to the top, of 3.8 hours. So I have, just make a little chart here. I have 10 milligrams at t equals 0. I'm going to have 5 milligrams at t equals 3.8. Let's see, 3.8 doubled is 7.6. I'm going to be down to 2.5 milligrams. If I add 3.8 to 7.6, let's see, that's going to be 11.4, I believe. I'm down to 1.25, and I was asked for at 12 hours, which is just beyond that, so that my values less than that makes sense.